evening, everyone. I hope everything is going on well. Okay, so I remember that my previous session we had learned about the long division method, right? So to become more familiar with that, we'll be practicing few sums today. Okay, so let's begin with the first question. The first question says, find the least number which must be subtracted from 3000 to 50 so as to get a perfect square. Also find the square root of the number so obtain. So the question means that we have to find the least number. That least number can be a whole number, natural number, any number, which must be subtracted from 3000 to 50. That means if that number is considered to be x, we have to subtract it from x minus x to get a perfect square. Right? So as it becomes a perfect square, that means is it a perfect square? We have to check, right, whether it's a perfect square or not. Then the answer which we obtain, we find x, what is subtracted 1 or 1 or any number, I suppose 1, that's fine. So any number we can take, and when we subtract we get some answer, and that answer square root, then we have to find. So this is what you have to do in the question. So let's proceed. So we have learned long division method, so we'll proceed with that method itself. Okay, so the first step in long division method is 3000 to 50. So we have to pair them, right? Starting from the rightmost, our right. Then 5 as a 25, we can take it. 6 at 36, we can't take. We have to take a square, right? What no, we are going to place the same digit over here also and over here also. So we'll take 5 as a minus 25. It will be 12, 2. Same like in division also we subtract. Here also we have to subtract. Next step is to bring the next pair down. Yes. The next step is to add it to the quotient. We get 10. Now we have to place a number over here. If here we are going to place x, here also we have to place x. That means this into x should be equal to 750 or near 750. Okay. So let's see which number can be placed over here and here. You can even place a dash over here if you want to mean that we have to place the same digit. So we'll see 106 into 6. So result. Same digit as I had told you. We have to place the same digit. Here also we had placed the same digit. 6 at 36. 0, 3, 6, 36. It's somewhat near. We'll see about 7. We know that it's 6 over here. So we cannot get 105 into 5 because it will become more smaller. We are going to get the closest one, right? The closest one. That's fine. 9. We'll check if there can be a little more. Yes, 749. That means here 749 we can take it. Here we can take 7. 7. Yes, 107 into 7. We have to neglect this number for the second step. Is equal minus 749 is equal to 1. That means, what does it mean? It means that 1 is the least number which must be subtracted from 3000 to 50 so as to get a perfect square. That means if we subtract 3000 to 50 minus 1, we are going to get a number. And that number is going to be a perfect square. Let's check it. It's going to be 3249. It's a perfect square. But of which number? Are we aware of it? No. For that we have to again go with the, we can go with the long division method itself because that's going to be easier for us. So if we take 3000 to 49, first thing is to pair the numbers starting from the rightmost. Then we're going to take 5 5 minus 5 5 is 25. Then again the same thing is going to run 749 this time plus 5. We have to add the divisor with the quotient. It's going to result in 10 and we have to place a dash over here and here the same digit. So I think we had seen that 107 into 7 is 749, right? right? So it's better to take 707 into 7 minus 749. That implies the square root of 3049 is equal to 57. So haven't we completed this one? Right. So next, let's proceed with the next question. The next question states that find the least number which must be added to 6412 so as to get a perfect square. So in the previous question we had subtracted, now we have to add. But you might be thinking that you have to go through the same method and then the remainder you have to add. No, we are not going to do it in the similar way. It has a different step. Let's see what are the steps. First, we have to see between which two square numbers 6412 lies. Okay, between what is 80 square? 1600. What's 81 square? It's not 1600. I'm asking about the square number, so it's 6400. 6400. Okay, so it's somewhat nearing to it. And what's 81 square? Shall we check it? You know, we can multiply and check also. Six five six one. Okay, so that means we can conclude that 6412 lies between 80 square and 81 square, right? Now which is more nearer to 6412? 6400, 6400 or 6561? Which one is it? It's 80 square. That means we have to, it's, yes, but there is one problem over here. We cannot take 80 square approximately because they are asking that what must be added to it. So here we have to subtract 12, right? So it is not possible. So we have to consider not this one itself. Okay, so what must be added to 6412 so as to get a perfect square? So we know that 81 square, that is 6561, is a perfect square. So we will subtract 6561 minus 6412 so that we come to know that what must be added to this number to get a perfect square, right? Yes, 149. So the answer is 149. So therefore we can say that we have to add 149 to 6412 so as to get a perfect square. What is the least number, right? So that's why we have to take this 81 square. If we proceed with 82 square also, we can take it because it's a number which can be added, but they are asking about the least, the closest one, right? That's why we have to take 81 square. So next part says, also find the square root of the number so obtained. So when we add 6412 plus 149, you know the answer is 6, 1. Right, so what is the square root of it? It's 81 square. Either if you want to check it again, you can go with the long division method, or you are already aware of what is its square. If you have given, if it's of more marks, then you can do the long division method and check it again. 81. Right, so are we done with these two questions? I hope you all understood it, and thank you. And if you have any doubts, place it in the comments.